In math this year, we have avoided providing our students with procedures or algorithms, focusing instead on allowing them to uncover relationships between numbers on their own. A week ago, we introduced them to the Candy Problem.
So first I looked at if two kids share all the candy so that each one gets the same amount of pieces. If two kids share all the candy and there are no candies left over, then the number of candies is a multiple of 2. But then there's one candy left over. And how many candies are in there? It has to be an odd number.
Okay, it can't be any odd number under 11. Because 11 works for 6 kids, but not 5 kids. So that means none of the lower numbers can.
What I did was I just tried a bunch of numbers up here, and then finally I wrote only odd would work, and it could not end in 5, 2, 3, 4, 6, 8, or 0.
I was looking at the 5 and see to see what would work for 5. Like if you start at 20 and then you go up 4, that would be even. So then I started at like 25 and then I went like up 4 and then it would be 9. So then I looked at it would be that it has to end in 9 for it to only work for the 5.
And then we needed to come up with an odd number that would be 4 away from the 5, which is 9. If 3 kids share the candy equally, there are 2 candies left over. Then that means it cannot be a multiple of 3.
So you eliminated a bunch of options?
Yeah. And then there is still 19 and then 29. But then 19 gets busted because 18 can be divided by 3.
59. It just really worked out well.
I knew 9 would always work for 2, so then I went to the 3, and I knew I already tried some of these numbers. So then when I went to 59, I saw that it was 2 squares. So then I knew 59 would work for 2 and 3. Then I went to look for 4, and then I just looked for 5, and then 6, and then I just got that 59 would work for all of them.
Yeah. Okay, so you're splitting 59, and what's the first column again? What is that?
How many needs to be left over and how many people I'm splitting it upon. 59 minus 5 is 54. And that needs to be a multiple of 6, which I should have multiples of 6. 54.
So, did you find a solution?
Yes.
What's the solution?
The solution would be 59.
So 59 candies in the bag works for every single one of those clues.
Yes, it does.
Boom! Feels good, hey?
Yep.
So I thought that I know the number that has to be left over is 1 less than the number of people. So that means that the number has to be a multiple of the number of people minus 1. So I found the least common multiple of 2, 3, 4, 5, and 6, and then subtracted 1. So this here is what I was doing to find the least common multiple. I figured out that was 60, and then subtracted 1 to get 59.
Allowing students to work independently and then in collaborative groups has provided them opportunities to discover, explain, and connect their own strategies and solutions with those of their peers.